Welcome back. We're going to continue our look at looking at the exponents and radicals properties and kind of moving back and forth between writing things in exponential form, writing things in radical form. In exercises 1 through 4 here, we are asked to write each expression in the form b to the m over n for a final answer. If a numeric expression is a rational number, then write your answer without exponents. Okay, so let's see what we've got here. It doesn't really say what kind of properties we can or cannot use here, so we're kind of free to do whatever we want. Since we have the same base, right, and we're multiplying, what can we do to simplify our exponents here? And the answer is we can add them. So it's 2/3 plus 1/2. Again, to add two fractions, right, we need a common denominator. So we're going to do 2/3 plus 1/2, which the common denominator here would be what number? What's the smallest number that 2 and 3 both multiply to be? It's going to be 6, right? So we'll multiply this by 2 over 2 and multiply this by 3 over 3, which yields 4 over 6 plus, actually I'll do it down here. We have 4 over 6 here plus 3 over 6, which gives us 7 over 6. So this will be equal to b to the 7 over 6 power. Okay. Here we have a base and a power raised to a power. How should we simplify? Multiply the powers. So this becomes b to the negative 2 over 15. Or if you like to leave it as a positive exponent, b to the 2 over... Actually, you know what? No, we're supposed to leave it like this according to the directions, right? Because of what it said right here. b to the m over n. Okay, here, what can we do here? Well, we're multiplying. Same base of 64. What should we do with our exponents? We should add them. Okay, again, don't have a common denominator, so we have to get a common denominator. I'll do that little side work over here. Okay. Multiply the top and bottom over here by 2 over 2. Multiply the top and bottom over here by 3 over 3. So we have 2 6 plus 9 6 is 11 sixths. Okay. At which point we could stop here and just say that's the answer. If you want to get more fancy, we could say like, oh, 64 is 2 to the 6th. And if we multiply, because again we have a power raised to a power there, if you multiply those powers, you're going to get 2 to the 11th, right? Because 6 times 11 over 6, well, this is really 6 over 1. 6 will simplify out. Actually, you could think of it this way. Let's do it this way maybe. 66 over 6, which is just 11. And so there's our final answer. Okay, debatable about which one they want us to put there, I'd say. All right, next, same situation here. We'll distribute the power, right? So we'll get, and we'll multiply when we distribute. So it'll be 9 to the 9 halves over 4 to the, well, 3 halves times 2 is 3. Okay, let's see here. And then neither of these, though, are really in that form. Right, your answer without exponents, it says. Okay, so I guess we're going to rewrite this without exponents. So we'll say square root of 9 to the 9th over 4 to the... Oh, but they don't want exponents? Interesting here. It seems a little bit intense. Mostly because the square root, I mean, 9 to the 9th is going to be a gigantic number. I'm not going to... Yeah, okay, so 3, 8, 7, 4, 2, 0, 4, 8, 9. There's 9 to the 9th. Over, and then 4 to the 3rd is 64. Okay, so there it is. All right, let's continue on here. Rewrite the radical expression so that no perfect square factors remain inside the radicals. In other words, we're going to just simplify this radical expression here. So here's how we're going to do that. We're going to kind of break this up and make it root 48 times root x to the 5th times root y to the 4th times root z squared. Okay, so we have simplified square roots of 48 before, the square root of 48 before, or square root of numbers before. So we're going to break this down using, into perfect squares. We want to create perfect squares. So 48 is the square root of 16 times the square root of 3. So you see a perfect square here, and then the leftover piece, the 3. That leaves us with 4 times the square root of 3. Okay, actually I'll separate it with this blue. Okay, on the other hand here though, we have x to the 5th. X to the 5th is not a perfect square, but we can kind of break out perfect squares from it. We can say, okay, that's x to the 2nd times x to the 2nd times x to the 1. And again, why am I picking these 2's out? Because we're trying to take the square root, and so we need x squared in order to simplify nicely. And then the leftover is that x to the 1. Okay, and so then we can say, okay, square root of x squared is just going to be x. Square root of this x squared is going to be another x. And then this square root of x we can't take, so we have to leave it underneath. Okay, y to the 4th, we can break that apart into y squared times y squared. Square root of y squared is just y. Square root of y squared is also just y. And then finally the square root of z squared, well, that simplifies just to z. So we put all these pieces together, and we get 4 x squared, I'm going to take these x squareds out, y squared, and the z. Now we're left with the root x and the root 3 here. So it's going to be root 3x, still in the square root there, and that is our simplified answer. Okay, we will see you in the next video, looking at some more of this stuff for exercise 5.